Welcome and thanks for joining this online lesson of the Stories project. My name is Giuseppe Di Florio and I'm a researcher at the ENEA, or that is the Italian National Agency for the New Technologies, Energy and Sustainable Economic Development. In this online lesson, we will talk about the safe and sustainable by design approach applied to the energy system and storage. This approach has been developed due to the stimulus of the European Union and is intended for a sustainable design, production and use of chemicals and materials. In the next, we will first make a recap of the time steps that led to the final guidelines of this method. Afterwards, we will revise the general concept, the basic idea behind this approach and this methodology. And finally, we will have a look at how this methodology has been already used in the research sector, but with a focus on the topics of energy, regarding energy materials, energy components, devices, and so on. So, as I said, let's start with a kind of timeline about this method. It is possible to say that regarding safe and sustainable by design, it is founded in the time of the Green Deal and in the chemical strategy developed by the European Union for the sustainability of chemicals. These documents aimed at a climate neutral, pollution free, sustainable and circular economy all over the continent by the year 2050. Let's say that the first document by which we can date back the birth of a safe and sustainable by design method is from March 2022. In this document, the Joint Research Center published a review of methods, indicators and tools concerning both safety and sustainability aspects of chemicals and materials. Afterwards, later in the same year, a framework named Safe and Sustainable by Design for Chemical and Material was indicated by the Joint Research Center, and this document constituted the base for what was later a EU recommendation that established a European framework for the safe and sustainable by design of chemicals and materials. In 2023 and later on in 2024, we have that the Joint Research Center applied the SSPD framework to some few case studies and came out with other two documents. One referring to these case studies and so also with some concrete, let's say, application, and later on with the guidelines for carrying out the SSPD studies. At this moment, let's say this is the final document that we have. By the way, maybe it's necessary already to anticipate at this point of this lesson that the safe and sustainable by design approach is on a voluntary basis. So there's nothing binding producer or manufacturer or other different stakeholders to employ this methodology. Apart from the fact that they can use it as a tool to boost innovation and improve the sustainability and safety of the products that they produce. Concerning the basic ideas behind the SSPD methodology, let's start with the goals of the method itself. These are to steer innovation towards green and sustainable production of all the industrial processes connected with a material or a chemical. Second, it's to substitute or minimize the use of hazardous chemicals or substances of concern. And third, to reduce or as much as possible to minimize the impact on human health, climate or ecosystem along all phases of the design, production, use and end of use of chemicals and materials produced in the European Union. These goals can be attained with some, let's say, main drivers that are, as we said already, the minimization of hazardous chemicals for the safety aspects, or the reduction of greenhouse gas emissions, and attempt to facilitate the reuse and recycling of the produced materials. From a methodological point of view, there are two characteristics of the method to be mentioned. First, that the safety and the sustainability should be assessed all along the life cycle of the material. And second, this framework wants to merge in a unique method both aspects of safety and sustainability. It is important to recognize that the framework can accomplish different purposes, and moreover, it can intervene in different aspects of the manufacturing. Let's take an example and think about a material that is used in a given product. Of course, this product is used in a specific application. And now, let's imagine that we want to improve the performances of the product, or maybe we want to reduce the hazard connected to the manufacturing stage of this product, or even maybe we want to improve the sustainability of the product itself. Now, we can use different design strategies. So, from one side, maybe we can think to design a completely new material with better properties, or maybe another possibility, an alternative is to redesign the product, and in this case there are several options, like the substitution of the material used with a better one, or the improvement of the performances connected with a certain material, changing some processes connected with its manufacturing, for example. In all these cases, anyway, the SSPD frameworks take advantage of some general principles that are the one that are also used in green chemistry, green engineering, and so on. And further, there are several principles that must be considered once that we want to design or change the design of this material. This design principle can be listed in material to enhance the material efficiency, to minimize the use of hazardous chemical, the use of renewable sources, for example, or to prevent the emission of substances of concern, or to already design the end of life of this material, and to maybe reduce the exposure to hazardous substances to the worker. The innovation process, that is what we can generally refer as the design or redesign, can take measures at different scales and also at different stages along the entire life cycle. So we have levels of the redesign phase, and at the lowest one there is the molecular design. Molecular design, that is the design of a chemical or of a material with certain physicochemical properties. And some example could be the reduction of toxicity, or improve some material performance that are of course related with the application of this material. But then at a second level we have the design of the product that shows better safety or sustainability performances. This is usually driven by the function and the characteristic of the products, and some example of improvement of the safety or the sustainability of the product can be, of course, the minimization of releases of the materials or lack of materials along this entire life cycle, or to improve the durability of the product itself, or improve the efficiency of the materials or the energy efficiency in the manufacturing stages. At the last, we can have also the level of redesign connected with the processes. In a sense, here we improve the properties of the product, or the sustainability or the safety of the material, um, acting on all the processes that are, let's say, around the manufacturing or the end of life stage or the use of the product itself. And some examples in this case are, for example, the use of renewable energy in the manufacturing stage, or the minimization of the scrap, or also the possibility to avoid emission of chemical of concern along all the stages of the product, and so on. Up to here, we have seen the general principles that should drive the process of design or redesign in a safe and sustainable way. But the framework contemplates also an assessment procedure. In other words, the possibility to have an assessment tool that quantitatively, or at least in a semi-quantitative way, can measure the efficacy of the design or of the selection of the proper material or the substitution of a material with a better one. In this slide, we see how to proceed in case that we have a given function. In this case, the function can be to keep dry. So the aim is to choose or design the best material that can attain this function. And the first step is to identify several options, and so have a selection of candidates. Once that we have these candidates, the next step is to describe the life cycle and map all the potential impacts that we can find throughout the life cycle. At this point, we need to consider the raw materials or the production processes for producing the material and the product itself, the use of it, and also the end of life of the product. Of course, for let's say with potential impact, what we mean is to look at indicators, and these indicators can be safety, the use of resources, and of course then the circularity of it, the emission of greenhouse gases, or other kind of impacts on the ecosystem like pollution, toxicity, and so on. Once that we have mapped the potential impacts, the through assessment is part of the third step, where the sustainability and the safety performance of all the alternatives are carried out. And then in the fourth step, through a scoring procedure, it's possible then to select the most sustainable option. I want to mention also that in the latest document, in the newest one, there is also a fifth step that anyway is optional, and is to consider also the socio-economic assessment of the different candidates. But this is, as I said, an optional possibility. Something a characteristic feature then of the framework is the fact that we need to combine different dimensions. First of all, safety and sustainability that are expressed with different units, and combine them in a certain way, so to have the possibility to express and compare different candidates with a unique indicator. In this way, regarding this, the methodology and the guidelines, they give some suggestions, usually regarding multi criteria decision approach, and that we will see in the next slide. But let's see a bit more in details how to evaluate the safety and the sustainability dimensions inside the framework of SSBD. Regarding safety, the guidelines say that there are several methodologies that can be applied. For example, the European REACH regulation. And in this case, the risk is a convolution of hazard and exposure. The risk of a chemical substance is not just how dangerous a chemical substance is, but needs to consider also the probability to be exposed to that substance. Somehow it accounts for the level of exposure too. Therefore, the assessment goes on this scheme. On one side, first classifying the hazard connected to the substance object of the study. The next step is to characterize the dose response of the chemical. In a sense, it's like answering the question, what are the consequences on health due to the exposure to a given dose? Once that the dose response is characterized, the next step allows to evaluate the predicted effect level, the PNEL. On the other side, what is needed is to assess the level of exposure or the quantity that could be released in the environment, and this in the SSPD framework should be done throughout the life cycle. From this is possible to assess the predicted environmental concentration for this specific case, the PEC, and as final step, the combination of these two indicators gives the risk ratio. For the assessment of sustainability, the framework gives some recommendation and suggestion. First of all is to use some life cycle thinking approach, and therefore LCA can be the proper tool to use. And second, for the impact assessment, the framework recommend the product environmental footprint, and the reason is that both methods have been developed by the European Union. Another recommendation regards the use of a reference chemical or reference material for the comparison, and in case that there is not for this application already a reference, to make a comparative analysis between the different alternatives, of course. Other aspect regards the system boundaries. It is prescribed to use a cradle-to-gate approach when we are dealing with a material but we don't have already defined an application for it, or in case that there is already a defined application of this material, to use a cradle-to-grave analysis. In this scheme here, we see all the processes and all the steps that should be inside the system boundaries. And so let's make something a bit more schematic. We can think to start with precursor and raw materials with their own value chain. From this we have the precursors, and then we have the synthesis of the chemical of the material. So with the chemical of material synthesis, this gives as an output the chemical or the material of reference. This one is then further processed to have the product. So we have the product manufacturing, and from here then we have the product that of course will be used in the application, and at the end of life there is also a step concerning the end of life phase. Of course, as usual in life cycle approaches, for all these stages there are inputs needed by the processes, but to this process are also connected emissions, usually emission to air, water, and soil. The safe and sustainable by design approach forces that the safety should be assessed for these stages, so the stages connected with the synthesis of the chemical or the material. Of course, the hazard, because it's intrinsic of the material itself, is uh, connected only with this stage, and the safety is also connected with the end of life, because there are processes in which workers can be safe and cannot be in contact, let's say, with substances of concern. And regarding the use phase, we need to look at safety for human and also for the environment. For all these processes, we need to perform the environmental sustainability. And as said before, regarding the socio-economic, in case that we are able, we want to do it, this also should take in account all the stages. At last, in the framework, there is the scoring step, so the the part of the assessment in which we are able to build a global indicator, and this allows to compare the different alternatives. Also, in this case, there are some recommendations prescribed. One is to use some minimal level of performance, so something that ensures that for all dimensions we have some minimum standards. And second, this minimum score could be also linked with national or European regulations for environment or safety also. A third aspect concerns the use of weighting factor. This is related to the fact that very different categories, impact categories regarding the environmental but also the safety, should be merged together, and the use of weighting factor can be a tool for having then the proper scoring and combination method. Usually, as I already said at the beginning of this lesson, for the scoring step, different options are used, but the guidelines recommend to use anyway something based on multi-criteria decision making. However, I want to stress here that if the assessment part of the framework is it's how to say, it's already done in a sense, and it's pretty clear how to do it. The scoring method, to the best scoring method to use, is still a matter of some investigation. Let me conclude this part of the lesson having a look at the timeline, not only the one that has already passed, as we have seen also, so there has been in the 2023 a feedback collection, so several stakeholders have been involved and gave their feedback. Some workshops have been realized, and some guidance report were produced by the Joint Research Center, that are the reports that at the beginning of this lesson I showed you about the case study first, and then the guidelines, right? But what is important is also that we will probably see a revision of the framework in this year, in 2025. For the rest of this lecture, we will focus our attention on the application of the SSPD framework to the energy sector, and to be more specific, to the research paper that can be found in literature in which the author have used this instrument for their studies, for their research. So what we are going to present is the review of the scientific literature that has been done with a search on Scopus on December of 2024, using the keyword safe and sustainable by design, and this combination of words could be found in the paper title or abstract, or the keywords. So, about the results of this search, first we see that in the last year, so starting from 2019, let's say 100 of publication mentioning safe and sustainable by design can be found, and about the temporal evolution of the number of this paper coming out, we see of course an increase in the last year, especially in 2024. The number of papers mentioning SSPD has been almost 3 times what was for the previous two years. And concerning the nations from which this publication came, of course there is a dominance of European countries, but the main contributors are Italy, Netherlands, Germany, and then even if not in the European Union, there is the United Kingdom, and so on. But what probably is more important for the aim of this lesson is how are segmented this publication per discipline or subject area. The main subject area regards the environmental science in a broad sense. And second, something not surprising, we have with 13% of publication refers to material science, and then there is 11% of referring to chemistry, or also to engineering. But what is important for our purposes is that 6% of these 99 publications are also somehow connected with energy. To conclude the analysis of these search results, it's possible to notice that the majority of these publications are research articles, but also there's a relevant part of these documents that are represented by review studies, but the share of editorial, book chapter, and conference paper is quite small. Regarding the keywords chosen by the authors of this SSBD document, it is possible to notice how it is very frequent the use of some words like sustainable development, life cycle, human, but we also see a certain use of the word nanomaterials. In this aspect, maybe this is an evidence of the tendency of a researcher to use this tool to assess, for example, toxicity or also other aspects connect with this. This that is just a part of material science, even a relevant one, and so to employ this framework, especially for advanced material or nanomaterials. For the rest of this lesson, then we will review this paper connected with energy and safe and sustainable by design, and we will see that in some cases SSPD is used only in a qualitative way, while in other cases the SSPD are just using just the principle of the framework are used for the innovation and to the design of the object of the study. Another aspect by which these SSPD energy papers can be fractionated, let's say, concern the object of the study. We will see that few of them consider devices for energy storage or for energy conversion. In other studies, just the materials, so materials tailored for some specific energy application are considered, and at the end also in other studies the safety and sustainability is assessed for materials that could be applied also to energy products, but are not specific for energy products. First document I want to show you is a review from 2023 with the title Lifecycle Thinking and Safe and Sustainable by Design Approaches for the Battery Innovation Landscape. And this is the only document completely dedicated to batteries. Essentially, it is a literature survey on different battery technologies, precisely 22, in which the authors try to define which parameters can be relevant for a safe and sustainable by design assessment for the battery sector, and in which they stress the connection between the life cycle thinking and the SSPT approach. Concerning some results that they can draw, they found that it is possible to get a balance between the functional performance and parameters linked to safety and sustainability. And these parameters that they say are important to evaluate are the criticality of materials, in this case, the safety, of course, and environmental impact, but also they stress the important aspect, also the social impact, the functionality, and the circularity of the materials used for the battery. They also try to develop some strategies and also how to communicate the results of safe and sustainable by design of batteries, but essentially they don't perform any global assessment or any scoring between these 22 types of batteries. They just try to find which are the parameters and the criteria to be met for a SSPT assessment of these energy items. A second document is a paper that came out in Journal of Cleaner Production in 2024, and in this case the authors deal with the application of tiered human health and environmental risk assessment to develop a safe and sustainable by design perovskite-based devices. Precisely, they assess some metal halide perovskite-based devices in which they take in consideration essentially the human health and environmental risk along the entire life cycle in a tiered approach that is following the development stages of these new devices. And also they consider what are the implications of the emissions in the environment of some hazardous substances. Some conclusion that they get, considering the three tier, in the first one, that can be, for example, connected with a low TRL, they just perform a qualitative assessment of the relevant risk connected with the production and use of these perovskite-based devices. And anyway, they found that compared to conventional solution, perovskite-based materials would anyway show low risk and moderate benefit. Looking at the tier 2, so that could be linked to a medium technology readiness level, what they do, they perform a hot spot scan and a semi-quantitative analysis, and they put in focus the use phase. For this reason, they found that it's critical to avoid as much as possible the emissions of lead from this material. And also another critical point, another hotspot is the possibility of some solvent release in the production stage. This, of course, is important for safety of the workers. In the higher tier, so the tier 3, they do a quantitative assessment of the complete environmental release, and they also look at human health using a model that is part of several impact assessment methods in LCA, that is the US ETOX model. What they found is that the highest impact is connected with the manufacturing, especially of the precursor ink fabrication for materials like some iodine of cesium and leads. And regarding the impact over the use phase, this is highly dependent on the scenarios taken in consideration. The third paper deals with photovoltaics too, and precisely with advanced materials for emerging photovoltaic system. In this review literature paper, the authors consider different kind of solar cells like organic, dye-sensitized, perovskite, and so on. They find out that the prospective LCA could be an important tool for the assessment of such materials, but in the paper this connection is just indicated as a possibility. And third, SSPD is considered especially in connection with the ease of recyclability of the materials. Some results that they, or let's say suggestions with which they came out are that the regulation, the end of life management of conventional photovoltaics should be expanded and adapted to the emerging photovoltaic system, that recovery of the materials, especially lead and titanium dioxide, would be advantageous for environmental reason, although actually presently is not advantageous yet. And third, the manufacturing of solar equipment possibly should be relocated in countries with a lower environmental impact. And the fourth point that we mention here is that special legal regulations should for advanced material, for emerging nanomaterials, it's necessary to minimize the possible risk of release of pollutants. Regarding this article published in Optical Materials, the authors designed and developed a hybrid nanostructure for the conversion of solar energy. And the important feature in this paper is that the authors used the SSPD principles and strategy to improve as we said, the innovation process. Some of the steps they took were to synthesize the quantum dots, but without the use of cadmium, employing functionalized cellulose as a biopolymer ligand. The synthesis was carried out in mild condition in an aqueous solution, and also what they did is to have a proof of concept with the fabrication of a photoelectrochemical cell. But anyway, at the end of this process, they do not perform any quantitative assessment of safety or the environmental damage. So, as SPD is used only to aid their research to use principle of SSPD. In a similar way, in this paper, the authors carried out an experimental study in which they integrate some silver-doped zinc oxide nanoparticles into perovskite devices. And in this case, they also used the SSPD framework only in a qualitative way, with the aim of driving the innovation process using some SSPD principles, but without performing any assessment or quantitative assessment of the safety or sustainability dimensions. To be more specific, they took some silver-doped zinc oxide nanoparticles that were produced with a modified soldier synthesis, in which they used a vegetable biocompatible polymer. They used the nanoparticle as electron transport layer, and this led to an increase of especially the energy conversion efficiency, and compared the material and the property that they got with the conventional synthesis in which ethylene glycol is used. I want to finish this lesson showing you just other two papers that anyway regards relevant materials or chemicals for energy conversion or energy storage, but are not the main focus of the paper. In this case, the authors address the safety and the sustainability in a quantitative way of some nano-enabled multifunctional materials. The application they have in mind is metal additive manufacturing, but of course these nano-enabled materials could be also part of some energy device. And what they do is they identify the potential safety and sustainability issues, and they assess the toxicity and ecotoxicity of different materials. Also, they try to estimate the emission of nanoparticles during the processing of these materials, and they also perform an LCA to identify the hotspots and also to get some hints how to potentially improve the environmental performances of these materials. Also, what they do, they in this case combine hazard and the process safety with the LCA. The study in this way consider three steps of the one that we have seen for SSBD. So the hazard assessment of the chemicals and materials, the assessment of human health and the safety in the production and processing, and step 4, so the environmental sustainability assessment. To conclude, I show you a paper about nanotitanium dioxide. The authors used as a case study to assess the safety and the sustainability of these materials, of course, and in which they use prospective life cycle assessment. What they did in this study is to identify some reference products, select the KPI, and the prospective LCA has been used looking essentially at some aspect like the release of the nanomaterial. They also found some nanotoxicology data. The LCA was a comparative LCA in which the authors compare commercial nanotitanium dioxide with some nano-coated titanium dioxide with a copper oxide. The application was for photocatalytic production of hydrogen, and some specific results they got are that the global warming potential and the energy demand decreased for the nano-coated titanium, but the toxicity, the human and also the ecotoxicity increase. However, also the authors put in evidence the fact that for these materials the uncertainty remains quite high. And with this this online lecture is over. I want to thank you for your attention, and you can find also my contact detail here in case that you have any question. Feel free to contact me.